Hello class, this is Paul. I'm going to be focusing on Lab 3 today. So we're going to use the fifth question from Lab 3 as our example question, because if you can do that one, you can do all of the rest of them fairly well. Before watching this video, you should review the PowerPoint, which will be uploaded on Blackboard. It's 5 slides long and gives a guideline of how to complete all of the things that you need to do. So let's take a look at question number 5. Hopefully you guys are able to see this. It says, present the 5 steps using R to run a one-sample z-test, copying and pasting the R syntax and output into the Word file. So that will be very important for this. You see a description of what we need to do. So to begin, the first step, as we've been practicing, is to state your hypotheses. In this case, the average score, the mean, is 22 for the population. So we already know what we're trying to test against. So the null hypothesis, we're looking to see if there's a difference with the general population. So the null hypothesis is going to be that scientists will have a mean equal to 22, the same as the population. The alternative hypothesis, sub A, is going to be that the mean of scientists does not equal 22. So what we're doing here is step 2, we're going to state the decision criteria. In this case, because we don't, if you read the description, it doesn't make a direction prediction. It's just looking for difference. So that makes it a two-tailed test, and you can look that up, and that means the Z critical score is going to be plus or minus 1.96. So step 3, in this case it says to use R, so we're going to use R. So to do that, we need to first define our object. In this case, it's going to be a capital X. So we do X equals and then C for count, because we just need the values. And put that parentheses, and you can copy and paste the numbers directly into the data file, and then hit run. And we've now defined our object. It can be helpful here to just take a look at our object and make sure that it actually is what we want it to be. And you can see all of the numbers are listed there. So it did what we wanted it to do. So next, in order to move forward, we're going to need to find the mean of our group. And since we've already defined the object as X, we can just do the mean of X. And there we have it. We can also, if we wanted to, go ahead and define the standard error. And we do that by taking the variance in the population and dividing that by the square root of the number in our population, which was 8. You can just count this number for that. And 4 was given to us in the description. It's the little lowercase sigma symbol. So we hit run. And again, just to make sure that we've got it right, we're going to take a look at the standard error, and it says that it is 1.41. we can go ahead and record those items under step 3 on our worksheet. And then step 4, we're going to go ahead and calculate our z-score. So this is our observed z. The z that we're looking for is something that is greater than plus or minus 1.69. So the z-score that we're calculating is going to be the mean of our sample minus the mean of the general population, which is 22, divided by the standard error of our means. So we hit run on that, and then z observed 1.06 is our observed z-score. 1.06 is less than 1.96. It's between those values of negative 1.96 and positive 1.96. So we do not have a significant enough difference, even though it appears like we might, because the mean for our group is 1.5 higher. That's not enough to be statistically significant. So you're going to report that, and then you're going to make your decision about the null hypothesis. And since z observed is less than the critical value, we're going to fail to reject the null hypothesis. And then we will copy and paste our syntax and output. What is helpful for that is you can go up here and select all of this, copy that into the document and paste it, and then go down here and individually do that. But the more efficient way is going to be to just come down to the console and grab the information that you need, because that will have all of the output that we need. And copy and paste that in, and we've completed item number 5. Hope this was helpful. Take care.